Right, okay, question 1. There is tons of writing on this question, so we need to read it. Okay, it's actually part of a database question, but it was relevant to the programming stuff. So we got various examples of some data. So we got something called student name, detail, points, and letter sent. And now they're giving us examples. They're saying like student name. Well, you could have probably guessed that. That's someone's name. Detail is a bit of text. Points looks like a number. Letter sent, it says true or false. And all it asks is, okay, what data type would we store this in? Right, so a name, we know name is text. So in programming, we call that string, don't we? The points one, right, when we're talking about numerical values or numbers, there are two things we could record something as. What are the two programming data types for numbers? Integer, and what's the other one? Float. Right, so in this case, does that look like it's, I don't know what it says. Oh, it's a conduct point, so that's just like, they're likely to be whole numbers. Yeah, so I would, if I was like looking just at the data, I'd say, well, they're all whole numbers, but really, they could have been floats as well, because you can have a whole number in a floating point number. Right, this last one seems to be the thing that confused most people.
So, was the last one integer?
No.
Float?
No. True or false values are Boolean values.
Sorry, middle one.
The points one, yeah. Integer or float?
I'll put that.
What?
I don't think I've got the mark.
What did you put?
Integer.
Did you put integer?
Yeah.
I'll come and have a look in a bit. You might have spelt it completely wrong. The spelling matters. Okay, in technical programming terms. Everything about programming is technicals.
It's not about programming. You can see the wires.
Yeah. Right, I am recorded. Right, the letter sent one is true or false. That is a Boolean value. Boolean. So anything where we've just got two values that you're going to record, if you was going to record whether someone for yellow or red, or whether something was on or off, they're suitable for Booleans. Okay, so there wasn't anything hard in that, but we have got to be able to do that. Given some examples of data, what would you store it as when you're programming? Okay, moving on. Right, okay, this is a standard thing. I have trouble with my A-level students with this. Constructs. It's a stupid term, but it's the term that's used. Construct is building blocks. So what building blocks? There are only 3 building blocks that we can use. Sequence, selection, and iteration. Now, it says identify 2 programming constructs. It didn't want examples. If it said give examples in the code, that would have been fine. But it just wanted you to say sequence, selection, and iteration. So, sequence is a given. If you've got more than one line of code, there must be a sequence. So you could have said sequence. And then the other one is obviously there's 2 for loops. That's iteration, remember.
What's number 1?
Sequence. So sequencing it, quite a few of you did start saying for and things like that, but it wanted the names of the constructs. So if they start talking about constructs, that's what they mean. Sequence, selection, iteration.
So
Right.
Number 2 is it?
Huh?
What's number 2?
Iteration. Sequence and iteration. Let me turn the projector on, you can see what I'm writing then. Right, then it said, what is a variable? Right. A variable is just this basic thing. It's a memory location that we reference using a name or identified by a name. So when we say like num, that's the first thing you can say. The second thing is that its value changes. But you have to be explicit about this. Its value changes during execution. That's what you've got to say. You can't just say the value changes. That's what the word variable means. We're giving it a context. So it's during execution. So as the program is running, the value of a variable can change. But please always say it's a memory location that we reference using the name. I'll put a copy of this on the Google thing anyway, so don't worry about trying to remember exactly what I'm saying. Just make some notes for yourself. Right, and then the next bit, which thankfully most of you did quite well, it said identify two variables. So if we look, we've got K, P and M. Okay. K, P, or you could have had M. Sometimes they'll say what line is it on and things like that. Anyone got any queries about that? So, can everyone see that they should have got 6 marks on that? If you didn't, you need to think about it. Right, okay, number 3. Logic error. Right. Logic errors are where we write code and it doesn't do what we wanted. So, it doesn't perform in the way that we thought we designed it. So I'm going to say, you can write this lots of different ways. Look at what the CGP book says. That's what you should be going back to. Okay? So performance of program isn't same as intended. That is a logic error. And I can't remember, I don't think anybody got the logic error on line 2. And it's to do with understanding what mod does. What does mod do?
Get the remainder.
Right, it gives you a remainder. Yeah? So if we do, let's just do a couple of examples. So if I do 3 mod 1, what's the answer? Not mod 1, what am I doing? It's mod 2, isn't it? Is what the question was. Well, that would give you 1, wouldn't it? What would 4? So that equals 1. 4 mod 2 is. What's 4 mod 2? What's the remainder when you divide by 2? Nothing. Right, so when you divide by 2, the remainder is either going to be 0 or 1. This is the standard... Yeah, pull the blind down, man. This is the standard way of checking for even and odd. Because if you divide by 2 and you get a remainder of 0, then it must have been a number that's even. If you divide by 2 and the remainder is 1, it must have been an odd number, which is what they're checking for in this program, aren't they? But the only 2 values that will ever be are 0 and 1. And they've put, if it's greater than or equal to 0, then print even. Well, every single time it's going to be that, isn't it? Because it's either going to be 0 or 1. That is greater than or equal to 0. So it should have actually been greater than 0. So the fix was to say if num mod 2 is greater than 0. Or you could have, you don't have to do it that way. Can I do undo on this? I can't remember. I think I have to go up here. Erase. A better one would have been to say oh, this is so annoying with this low resolution screen. If I'd have said if it's equal to 0, it's even. But they've put greater than or equal to, so the 1 gets included. So remember when I do equals, I have to do double equals.
That's it.
And that was it. Most of you sort of like repeated it. So always give yourself some examples for yourself. Okay? It's only 1 mark, but 1 mark can be the difference between 2 grade boundaries. 2 grades. Right, syntax error. most of you picked this up. This is where we've not followed the rules of the language. Okay, so we didn't use the language properly. So we didn't follow the rule of the language. And most of you got the error, even if you didn't get what syntax error was exactly. Right, so an example of that would be things like you've spelt a keyword wrong, haven't you? So you put fog instead of for, which obviously it wouldn't like. Or you've constructed something. You haven't put, in Python, if you don't put the colon at the end of a block start. Right, so what was the error? And I think most of you picked it up. They'd spelt print wrong. Common mistake. So it just needed to be print, and what was that, the odd one?
Yeah.
Yeah, so just odd in double quotes. Okay. Right, okay, next bit. Just checking that you understand what assignment is and how to write that in code. Write a pseudocode statement to assign the value 7.3 to the identifier timer. Standard process. We've been given the name of a variable, so we're going to write its name. To do assignment, we do an equals, and then we put the value. So that was ridiculously just that. Timer equals 7.3. And then the data type, it's a number, but this time it's definitely not an integer, is it? So it's a float. Remember, the example might also use the term real number. Oh, not read. Oh dear. A real. So don't be like, oh, what does real mean? They tend to come across float. Everybody uses it. Right, the next one was running through a bit of code. Dry running. Tracing. Right, so when we run this program, you've got to look at this carefully. I think most people got the very first one. So it says print score. Score is the name of a variable. So we need to look in that program for that variable to see if its value has been set. And I think on line 6 you can see score equals 18. So the output, when we print score, the variable, we'll get that. Then it says print name. Now there is something called name that's got Drew, but name's in double quotes, so it's a bit of text. So we're actually going to print name, aren't we? Because name's in double quotes, so it's just text. It's not an identifier of a variable. The next one, it says print, and it's got new score, score, comma 2. So we have to actually run that function first with the two values. Whatever score is, now we know score was 18. Okay, so what I'm going to do, I'm going to just write that down and say 18, comma 2. That's what's going to get sent. So if I look up new score, the two values are referred to as A and B, and it says A times B. So 18 times 2 is 36. And then it says actually add 1 to that. And that's the value we're going to return. So it's actually going to be 37. And then the final one says print score. Has score changed from what it was before? No, it has not changed anywhere in this code. So it's 18 again. We need to do more practice on those. Okay? We've got to do more practice on all of this, so don't stress out too much. Yes, you might stuff this up, but we can make improvements. I'm going to do another test, not next week, but the week after. Okay? With similar questions. Right, then we got to the last couple of questions, which were all about writing code. So, what did I say about these? What was my number one that you had to do when you had an algorithm to do from scratch? Don't try and do all of it. Look for the easy bits. So let's just read what we got to do. Recording sum of values. Enter a numeric value which is added to a total. So this is a running total problem, which initially starts at 0. I'm going to put that in straight away. Total equals 0. I will get a mark. Even if I get no further, I'll get a mark. Right. We're going to have some code that adds a value to total. So every time she enters a value, the total is output. So we also do that. And it does it 100 times. How in Python do we make something happen 100 times? What's the for loop for that? For? What's an there's a couple of different ways to do it, but there's an easy way. We need to come up with some variable name. We do that, don't we? For P in range, and then what do we put in the bracket? 100. Right. Guess what? I'm going to put the colon on because I'm going to do it in Python. That's it. I've done the loop. So I get the marks for that, making the loop the right size. So she needs to enter a value. That's input, isn't it? So I'm going to say val. I need to store it somewhere. Input. And I'm just going to put next number. Or next, whatever it was, result. Don't know what the experiment is. This was 6 marks, this question. So I've actually got at least 3 marks already. So every time she enters something, we add that to the total. So that was just total equals total plus the value. What have I missed? We'll come back to that. And it said every time she enters a value, the total is output. So we're going to print the total. I don't know why you want to do that, but that's what they want to do. Total is, and I'm going to put a marker, and I'm just going to say print out the total. I don't need, because I'm doing it in Python, that is it. It's finished. Program's finished now. But I've made one mistake that would trip up in Python. Anyone spot it? What do we have to be careful of when we're doing input in Python? What are we actually inputting? What sort of data? No. We're inputting a number, but what are we doing when we do input in Python? String. So this line's fine. This line is going to go funny. It's going to go, you can't add a number to a string. So I can fix that. I can either do the old int there. So I could have done, so the fix to that line, could have done it this way. Val equals int input, and do it that way. Oh, this one now. So I could have done that, or I could have fixed on this line instead. I could have done it there. I could have said total equals total plus, and then just do the int there. Both valid ways of doing it. Just to make sure I got a number. But even if I'd have done that, I've got 5 marks. Okay? And really, they should be fair about it and say, well, it is just an algorithm. We didn't ask you to write it in Python. So, we'd probably give you it anyway. Benefit of doubt. But was there anything hard in that little program, apart from remembering about the turning the string into a number? You could have put float as well, couldn't you? Because that's a number. No, but I read the question, and the people who left it blank could have at least, if they couldn't remember how to do a loop or input, they could have set the total to 0, couldn't they? Everybody could have. Yeah, you've got to actually. The thing that you've got to learn is Right, how do I actually construct all this stuff under pressure? Because it's different when you're on the computer because you can look it up, can't you? Which is what you do, to be fair. But some of these things we've got to just, it's practice. Right, and then we had another data type question. What is a real data type? Quite a few people bumbled an answer out on this one. It's sometimes difficult. So it's a numerical value with a fraction. Fractional part. And then it said, and you wanted an example. Some people didn't give an example. So I would actually say something like 16.35 as my example. Then it said, what is an integer? Integer is just a whole number, isn't it? It's a numerical value, which is a whole number. And the reason we have to worry about these things when we're programming is because the computer stores them in different ways. For the example. Example. For what? A whole number? Yeah. Just a whole number, man. Yeah, no, it's not a trick. It's not a trick, Aaron. It's not like a specific value you've got to guess. No, so I might put like 15. If I wanted to tie it to the other question, I could have put 16. But I didn't need to, did I? Okay, moving on. I think we had 2 more programming questions. Right, again, you get a blank page, and that can actually be quite scary. But we've got bullet points. So it says, write an algorithm, uses iteration, so they're telling us to do a loop, enter 10 values. Okay, count how many values are over 50. Output the count of values over 50 after the 10 have been entered. Right, so we've got to do a loop 10 times. So, when you're doing these, you might say, well, that's what I'm going to start with. So, I might need to do something before it, so I'm going to start a little bit down the page. How do we do a loop 10 times? What do we put? Bobby, what do I put? To do a loop 10 times. Yeah. 10. For P in range 10. That'll make something happen 10 times. Right. That will get you something. Or if you get asked to do some input, you do the input, that'll get you something. There is always marks to get, even if you're confused about what you've got to do. Right, okay, so we're gonna input 10 values. So I'm gonna put a bit of input code in. I'm gonna do it properly this time. I'm gonna say int input num. So that gets me a number in val. Okay, and it wants me to check. Is it over 50? How do I do that in program code? How do I test something? What's the command? If. So I can say if val. How do I say is something, is it say over 50? How do I say something greater than 50? Go on. Don't go on about crocodiles. I put greater 50. So if that is true, then we're going to increase this count. So I'm going to say count equals count plus 1. Right. If I'm doing a count, what have I got to do before I start? What I always have to do if I'm doing a counter, what have I got to do before I start adding to it?
Score equals 0.
Yeah, so you call it score, I call it count. But the name doesn't matter. Yeah, so before we start, we say, right, let's reset that. Make sure it is 0. We haven't got any counts yet. It then says it outputs the count of values over 50 after all 10 have been entered. So I don't do anything else in that loop. Down here, take the indent right back because it's after the loop. I'm just going to say found, and I'm going to say plus count, or I can put a comma, can't I? I'll put a comma, over 50. So I'm going to make a nice little message. And that's it. 5 marks. Right. Is there anything stupidly hard in there? Logic-wise? There isn't. It is just remembering, isn't it? So our core thing is, how do we test a value? How do we do a loop for a certain number of times? Okay, let's move on to the final question. The final question was slightly hard. No one really got close, I don't think. Right, we did this towards the end, and it doesn't help that we lost that last week. All right? What can I say? Right, they want us to get some input from the user. So it says, ask them to enter the number of miles and the age of a car. Then it says this important word, validate. To check that we've only got sensible values. So we've got 10,005. Right, so if we're going to check how many miles it's done, we need it to be under 10,000, but what would be a stupid value?
1 million.
Well, no, right. We can check to make sure the number's less than 10,000. Right, that validate is the key term. We've got a number here. We know it's got to be less than 10,000, but what's to stop me putting minus 500? That's what they want. When they say validate sensible values, you need to do what's the maximum we're going to let them put in and what's the minimum. So what is the minimum number of miles we're going to put on a car? 0. We might have bought it and never driven it. Okay? I don't think any car ever has 0 on the clock because they have to drive them off trucks and things. Right. So I don't know how I'm going to do all that yet, but I can see I've been asked to do some input. So I'm going to say miles equals, I'm going to make sure I get a number, so I'm going to do the input bit. And I'm going to say miles please. Keep it polite. For the age, I'm going to do the same thing. I only got 1 mark for that because they knew that was the simple bit. But I got a mark, which is better than no marks. So that's my opening. And I'll get a mark for that. Then it said, right, okay. Validate. So we're only allowed to output true if we've got a valid number of miles and a valid car age. Okay? So it's no good just one of them being right. So there's loads of ways of doing this. So I'm going to check the miles first. So I'm going to say, right, if miles, what did we agree the lowest value was going to be? 0. Yeah? So if we say if miles is greater than or equal to 0, now it said fewer than 10,000, so that means less than. When we've got to do a check and we need an upper and lower bound, we just say and. So we say and then miles is less than 10,000. Right, if that's true, if we can get the age to be valid, then we can print true on the screen or whatever it is we've got to do. So I'm going to do my next test. So I'm going to say, right, if that was true, let's now check the age. So we can say age. Right, what's going to be the lower end for the age that we're going to put? 0 again. So if we say greater than or equal to 0, we need to do more examples of these, but they're always the same. And then age is less than, what was it? 5 years old or less. So that's less than or equal to 5. Right, if both of those things are true, we'll end up there and we can print out true. I don't know why they want us to print out true, but that's what they want us to do. Right, if those two things are not true, so remember we put an else for that, so we're going to say else print false. So if that age wasn't valid, we want to make sure we output false. But also, if the miles wasn't valid, we're not even going to bother checking the age. There's no point, and we'll do that. So this was 5 marks, slightly complicated. There are different ways of doing this one. But it's a standard thing. They will ask you to do validation, and that's what you have to check, an upper and lower value. Sometimes they'll give you the 2 values. Other times, like this one, they'll say, what's something sensible? So we had to decide the bottom end. And that was it, 39 marks. Anyone got any questions? What I'll do is I'll show you another way to do this. Okay, so that we can do some testing first and then do the ifs, and it makes the ifs simpler. I don't think I've got any spare paper. Oh, there's a bit of space there. Right, so I'm going to do that one again. I'm going to assume I've got, so this bit I'm going to write in a different way. So, further solution. So I've got age and miles, that's the same. But I'm just going to write it slightly different. So I'm going to use the logic from those ifs. When I look at that and I say miles is greater than 0 and miles is less than 10,000, what possible answers could I get? When I do an if, what answers do I get from the condition I'm testing? What is it? Oh, it can only be 2 things. It's like a question. So when I say if miles is greater than or equal to 0 and miles is less than 10,000, what's the answer going to be? What does the computer give me?
Anything under 10,000.
No, true or false. That statement, when I do it, this is how you've got to read these. When I do an if, I look at the statement and I say, is it true or false? If it's true, I do the bit straight after the if. If it's false, I do an else. Yeah? Right, a true or false value. What did we say a true or false value can be stored as? Yeah, a boolean. And we can store it. So I can write like this. So I can say distance equals, and I can write this. I can say miles is greater than or equal to 0 and miles is less than 10,000. And that will give me a true or false value in distance. Okay? I can do the same with age. So I can say age, and it's obviously it's the same test I'm doing, but I'm just storing the result rather than using it. And miles is less, miles, what am I doing miles for? Brain going off. Age, you fool. Right, so if age is greater than or equal to 0 and age is less than or equal to 5. So I store those 2 values. What that then lets me do is just do a single if. So if both of those are true, I want to say, okay, print that out. So I can say if distance and age, why am I not saying equals true? I don't need to because they're already booleans. It's already either true or false. So I can say if it's true and true, print true. And if I can write this mega simple, this program, So I'm going to say print true, else print false. Whenever we look at any of these sort of things, we'll look at these different ways in which you can write this code. Because actually I could have written this in Python. I could have written this last bit as a print. I could have done print string. So this is another alternative. So this is an alternative to this. I could have written this. Print string distance and age. And that would give me the same. So I could actually do it in 5 lines of code. Well, yeah, 5 lines of code. Or I could do it a little bit longer. They all do the same thing. Right, I'll stop the recording.